Ready? Good morning, everyone. This is Computer Science 455, Software Engineering. And today we're going to talk about what this course is all about and everything that we'll do today is first time online, since this is the first time I have taught this course this way. Um, what we're going to uh, talk first is the course syllabus. And it's very important that we define what the course is all about and coverage and what is the requirements and how the course will be conducted. The the course has a prerequisite of data structures, so you only need data structures to take the course. And we will have 3 hours lecture and 3 hours lab. And you see there the my name, Dr. Concepcion, and all my contact information. You will see my voice phone number and my email. Um, we also have two teaching assistants in this class, Chas Hampton and Ben Alexander. You'll see the email address that is written on the course syllabus. The objective of the class is to learn about software engineering and what is the problem in software engineering is that we are lagging behind the output from the hardware um, part of computer science, where hardware are built based on um, units or components that have been working before. And so all they do is add additional components that are new, like a new pipeline system, and the pipeline may be a 10 or 10 segment for this time, but they design a 20 segment pipeline, and all I have to do is plug in that object or component into the old hardware and the whole thing works again. Can we do the same thing for software? And that's uh, the objective of the object-oriented paradigm. And the object-oriented paradigm is you build software components that can be reused in other applications. We are trying to do that, and there are many techniques that we have today, like object-oriented approach, which tries to copy the paradigm in hardware. Can we do that? Um, I would say that the software engineering field consists of five big parts. One is called modeling of software system. The next one is the methods of software development. The next one is the management of software project. The next is architecture and design and analysis of software artifacts. All of these studies are under the heading of software engineering, and we'll try to talk about this in a quarter, 10 weeks. but there is a field of study called software engineering. Actually, there is a Bachelor of Science in Software Engineering now, which encompasses all of these areas. There's a Master in Software Engineering, and there's also a PhD in Software Engineering. So software engineering is a field that encompasses computer science and project management, because you deal with people, and people are the most complex system. Uh, you can't predict what your programmers or software engineers are going to do in a particular project. So the general objective of the course is to gain practical and realistic experience in the design, development, and maintenance of software. So what I will try to do is to give you a realistic experience in the development of software from the initial idea of a client to a running prototype at the end of the quarter. How do we do that? We have to go through software lifecycle, software process, and software engineering. And the development of software today is much more complex than than 10, 15 years ago, because of the involvement of distributed systems, cloud computing, service-oriented engineering. All of those are new ways of developing software today. So it's much more complex than was being done, as I said, 10 to 15 years ago. We have so much complexity in a software that it has grown into millions of lines of code, and therefore we gotta go through some new paradigms on how to build big software today. How do we do that? The specific objectives of the course are we have to learn about the software lifecycle. So we begin with a document called Software Requirement Spec. How do you define what the client wants? And the client wants everything. We cannot implement everything that they want. First, they have to define it, and what they say may be a different interpretation on the software engineer. So we need to make sure that what they want is what you are writing down in this document called SRS. Another important document is the Software Quality Assurance Plan. And this is a plan on how you will test the software. It's not enough that we build the software. We must be able to test it, whether it fulfills the needs of the client. The next one is Project Management Plan, Software Project Management Plan. As you know, the quarter has been reduced to 9 weeks. So you only have a very limited time to actually produce a prototype. By the end of the quarter, you have 9 weeks. How are you going to plan what to do in that 9 weeks so that at the end of the quarter, you have a running prototype? Okay, so that's part of software development. We can't say to the client, it will be done when we are done. There is always a deadline, and there is always a limited resource to produce the software. So how are you going to manage that? Next specific objective is the software design. Software engineers are sometimes criticized for having a haphazard software process in producing software. And it's like building a house without a blueprint. You can't build a house without a blueprint, or a building without a blueprint. You cannot just build and patch up everything and produce the house that you want or the building that you want. There's got to be a design behind the construction of the structure. Um, Software is a very complicated system, and as I said, uh, today's software consists of millions of lines of code. Can you imagine building a 40 or 50-story building without a blueprint? You can't do it without a design. Next one is the software testing, and testing is the final phase in software development. We want to make sure that the software works, and sometimes the failure of the software could mean a disaster. And one such example of that is the Boeing Max 737. The problem there is that they installed bigger engines than the previous design, and they have to put the engine, I think, closer to the front of the airplane, and so the purpose of which is to save fuel because it's a very powerful engine. But the problem is on takeoff, the airplane keeps going up fast, and there is danger of stalling. And of course, when you stall, you have no control of the airplane, it will crash. So there is a software that was installed to monitor this tendency of the 737 to keep going up. It bring down the nose lower so that it will not stall. And of course, it was not fully tested that when the nose is put down by the software, it goes up again because of the engine not being controlled, that it should not keep climbing. And so there's a struggle between the pilot and the nose to go up and down, causing it to crash. So that problem, the software was not fully tested, and Boeing is in a big trouble today of paying damages to the people who were killed in two crashes. So testing is important because testing could cause loss of life. Software maintenance. When software is done, we just don't throw it away and then say, I'm done with working on it. Software maintenance is important because there are possible changes in the requirements, possible changes in the system, and therefore software needs to be maintained. It's not a one-time work that when we finish the software, the work is done. No, work continues. The prototype you will be completing this quarter will be continued development after this quarter is over. And there are many software projects that we have done before that we have been working on for 2 to 3 years now. And I'll show you examples of those that we have done before. So it's a living system. It must be maintained, or the software will not be able to function well. Okay. Team development is important. You must work as a team. Because of the size and complexity of software, not a single software engineer can do the whole thing. So you must be able to collaborate with your team members. And the team sometimes also, because of the size of the software, collaborate with other teams also. And so collaboration in a team is very important. You must be a team player to be able to survive. As a matter of fact, the last interview of a software engineer when applying for a job is an interview with the rest of the team that they will be joining. The interview is for whether they can work with you or you can work with the rest of the team. And if they find out that they can't work with you, even though you passed the previous interviews in flying colors, you may not be able to get the job because they cannot work with you. And so that's very important that you have uh, team team players frame of mind. Next one, we're going to talk about agile software development. This is a software development that involves the client as part of the team. You can't produce the software without the client's active participation. They're not be developing, but they are guiding you in terms of functionality. Are you building the software they want? And Agile doesn't build the software in one giant step. It is an iterative and incremental development of the software. In this class, we will do two iterations, one in the middle of the quarter and one in the finals. So you will have a chance to develop the first version, first prototype by the middle of the quarter, and then a second iteration by the finals. So we will apply agile software development to our project. Okay, so that's a specific objective, and then the last specific objective, I want you to be familiar with the definitions of these three terms, because these three terms are important to you when you are applying for a job. Make sure you can define these terms very well and differentiate between them. What is software engineering? What is software lifecycle? And what is a software process? Okay? So those are the specific objectives of the course. The text is the text by Brugge and Dutwit. It's a nice book that combines UML. In the book, it is entirely OO, object-oriented, and a tiny book called UML Distilled. This is a very brief book on how to use UML, and I want you to be familiar with the UML notation, because this is the design notation that we will be using. So keep that that book as a reference when you are doing design. Okay, there is a reference book, software engineering. I won't require this, but it is an additional book that talks about the new paradigm, like service-oriented software engineering, because of the cloud paradigm that we have today. Most of the software that's being built today is using service-oriented paradigm. So that I would recommend. Okay. Now let's talk about the requirements of the class. There will be a lecture, and so during the lecture, I will talk about principles and best practices of software engineering, and hopefully you guys will apply it to your projects. Okay, and since this is not an in-person lecture, it will be online, so you can view this lecture online after you can view it several times as you wish. Okay, now for the lab, you will have mostly mobile app projects, And you will be organized into teams. One project per team. Each team will have a management team consisting of a project manager and an assistant project manager. So the assistant project manager is going to shadow the project manager just in case the project manager cannot do his or her duty. The project assistant project manager can take over. The rest would be the development team, or I will call them software engineers. There will be a QA team in charge of testing the prototypes that is developed by each team, and the QA team will be led by a team lead. And the QA is the one responsible for passing or failing the prototype that is produced. So in some software companies, the QA team is the most hated team in the company because they control whether you pass or fail the testing, and it is a kind of a pyrrhic victory, because if the QA team wins, that means the software project fails. Okay, so but it is another team that does the testing, although the development team also does their own testing, like unit testing, integrated system testing. They also do those testing, but it is the QA that would test the completed prototype, and that prototype will be the one to be given to the client for further testing. So the class will have a set of deliverables. The deliverables are the software requirement spec, the software project management plan, the software quality assurance plan, the software architecture, detailed design, unit integration and system test plan, maintenance manual, documented source code, and I'm hoping we can have the public exhibition, presentation, and demo in the finals. Okay? All the meetings, lab meetings and lecture meetings will be online, and there will be no in-person lab in this class. Attendance will be checked by the project managers and team leads by sending an email attendance report to Dr. Concepcion. Okay, and each development will be assigned a mobile app project. I will show you the possible mobile app projects later, and the possibility that the project may have commercial viability. So you are required to sign an NDA. This is to let you know that what we are doing here is serious business. It's not a play toy that the project consists of. It is a real live project that a client is interested in developing. So, there should be no information coming out of this class about the project you are doing. The TA assigned to this class will provide the expert consultant in the development of the mobile project. So be sure to contact the TAs when you have problems. We will set up Slack for the different teams. So you will have communication among your teams, team members, and between teams, and also you can communicate with the TAs and myself in Slack. Okay, we will use UML for our graphics notation, and you will learn how to use Dia. Dia is a free tool to draw diagrams in the OOA object-oriented analysis and design methodology. So each team will be graded according to the deliverables being submitted and stored on time on the development repository. You will be given a tutorial on the repository we will be using, and uh, uh, as I said, you will apply engineering concepts and methods and techniques learned from the class. Okay, so the lecture hours, as I said, you will learn principles and practices of the software engineering. Okay. Um, the following are the details of your grade. So for your software requirement specification, everybody is required, the management team and the development team are required to write the software requirement spec, the software project management plan, SQAP, and architecture is the management team responsibility. The detailed design is the development team responsibility. The integration and system test plan, management team responsibility. Unit test, development team. Maintenance manual is a document that is used to give reports to the succeeding team who will take over your software, and this gives the hint on what to fix and what is good about your implementation. The source must be documented, responsibility of the development team. Tutorial exercises that you will be going through is 5% of your grade. Attendance is 10%. You will be evaluated by your peers, and I will also be involved in that, 10% of your grade. Whether you pass your prototype or not, that's 20% of your grade, and the total is 100%. So the grading, as you can see here, are using the letter grades. So the students grading, you will have a choice of a letter grade or a credit, no credit definition. So you will be given a choice which particular letter grade you are going to you want to have. And student with disabilities, here is the information about that. Okay, this list of publications which I include in the syllabus is kind of a bragging kind of thing. But I want to show you the development of this course through the years. We have published several papers of the software engineering paradigm that we are using in this class. So as early as um, as early as 1998, we've been reporting to the ACM Special Interest Group in Computer Science Education of the way I teach software engineering. So you see here in 1998, I published the first paper about this particular course, and it's called Using Object-Oriented Software Lifecycle Model in the Software Engineering course. So as early as 1998, we have been reporting to the conference on faculty who teach computer science about what's happening in software engineering. And then we move on to other papers. Let me point to you the paper that was published in 2005. That's the first time that I have taught the class as a mock software company. So I kind of simulate how is it to feel, how does it feel to work in a software company where you have real projects and real deadlines. And this was co-authored with former students in that particular class. So you'll see here the list of authors of, I'm the first author, but the succeeding authors are all former students of that class. And that's when I developed the idea that the project managers and the software engineers, the software designers, the QA people are actually playing a role in the mock software company. And of course, you would guess who would be the CEO of that software company. Okay, yours truly. All right, and so on, and and then our latest publication was in 2017, and this is where I tried to use personal software process, which is a training program done at Carnegie Mellon to train software engineers um, uh, in the art of applying software process in software development. So I try to mimic that in my class, and I have the students go through the personal software process. But unfortunately, uh, many of the students in software engineering didn't like it. Actually, what is happening is that they're doing the training and taking time away from their project, which is not a good result of that change in paradigm. But I just want to tell you that this course is evolving, and right now the course is a project-based learning, no quiz, no exam, as you will see in the syllabus. There are no midterms, there are no finals. Everything is dependent on deliverables, and I have proven that this paradigm is the best way to teach software engineering, which is project-based. And I would like to add role-playing as another paradigm. If the students play the role of, say, a project manager or a software engineer, he or she is mimicking his role in a software company in producing software. Okay? All right. So in the course outline, as I said, the lecture will be all about principles and best practices. So on this first week of class, we'll talk about, I'm introducing to you software engineering and modeling with UML. That's what we're going to do on the first week. And in the lab, you will have tutorials and skills, a survey of skills. At this point in time, you probably have filled up a survey of skills sent to you last week. So we should have that results, and Ben and Chas probably have results today about your assignment in the different teams. So we can organize this particular week and start the software life cycle, which is organizing and getting in touch with your client of what they want. And I'm assuming that at this point in time you have signed your NDAs. So the NDA should be given to you as a link, sign it, and then send it to the TAs. Okay? So send those NDAs. I'm hoping you sign it before you read the descriptions of the project, or else. But it is a a simulation of your responsibility of this particular project. As you know, we're trying to mimic the real world. So the real world is that there are IPs, intellectual property, that needs to be protected, and the client, of course, is interested in protecting their IP. All right. Um, so Ben and Chas have tutorials prepared for you this week and some programming, lab assignments that you should do to make sure that you guys have fulfilled the requirements. Remember, this is online, and um, the responsibility of learning the material rests 100% on you. We are not watching over your shoulders. You should do it yourself, and you submit the assignments that they require as evidence that you have gone through the tutorials. Okay? So that's the complete introduction of the lecture and what we're going to do for the rest of the quarter. I need you to sign the agreement that you have fully read the syllabus and that you understand and accept the requirements of the course. Okay? Please print that, sign it, and then send it to the TAs, Ben or Chas, depending on whether you are Monday or Wednesday group. Send that to them. Okay? All right. So, 3 times over. Okay. For today's, for the Mac software company that I showed you as a paper, this is the um, kind of a summary of what that paper is all about. Of course, I was talking about the how to teach software engineering using Mac Software Company. And we have gone through the course objectives. What is the course objective? And the course objectives are the ones we discussed a while ago. Of course, the overall course objective is for you to get actual experience in a software company, how to develop software. Now, the uh, uh, the role playing that I was talking about a while ago is for each of the development team to play a role in that development team. I mentioned project manager, assistant project manager, and software engineers. How many software engineers will depend on how many people are assigned to a particular team. There is another team called the QA team, quality assurance, and the quality assurance is led by a team lead with several QA engineers under the leadership of this team lead, and they are the ones um, uh, responsible for testing prototypes. As you see here, role playing is part of your learning process. Uh, if I tell you what's the role of a software engineer, uh, it would mean more if you are actually doing what a software engineer is supposed to do, rather than memorizing a, um, a job description or the functions of what a software engineer is supposed to do, as opposed to actually doing what a software engineer is supposed to do when developing software. Where do you learn most? Memorizing terms and writing an essay, or actually doing it? So I find actually doing it is more there is more learning there. Um, and in project-based learning, that instead of a a toy project that the instructor would choose, we have a an actual client, and the project based learning is an approach where the students learn by answering a complex question, a problem, or a challenge. So it has been proven that the students promotes the students are encouraged to do active learning and explore how to solve the real world problem in the study of software engineering. So you'll see here the client is actively involved with the development team, and when the development team has finished a prototype, I call it a prototype because it is not yet the completed project, but it is an incremental development of the product, software product, towards the complete implementation of the product itself. But we do it incrementally so that uh, you see the development progresses as you gain more experience with the development. Okay, and right here is the software life cycle that I am talking to you about. And so we begin from an idea from the client. You interact with the client, transferring his or her idea into a document called SRS. So you go back and forth between the client and the and you in translating the idea into a concrete document that both the client and you as a software engineer would agree that this is indeed the project you will be writing. Once that is done, the team get together and now plan. And the planning consists of, in the real world, the bottom line of the SPMP is the budget. How much dollars will it take you to finish the project? It all depends on how long the software engineers or the team will finish the project, because the 99% of the cost of the software development are salaries of the software engineers. You pay them as they work on it. So the uh, the SPMP will estimate how long it will take you to finish the project, and that would translate into the budget that you will need to finish the product. But since we don't have actual money here in our simulation of a company, we won't do that, and instead the deadline is fixed. And the deadline is fixed on the middle of the quarter to produce the first prototype, and the finals, which is the final prototype. So that is the software project management plan. So the team must be able to um, uh, assign responsibilities and duties to every member of the team. Make sure everyone understands their part of the development, and uh, and the steps that you're going to take all towards the development of a prototype, first on the middle of the quarter, maybe 6th or 7th week, and then uh, the final prototype, the second prototype on the finals. So the next step in the software lifecycle is the design, the software architecture and design. As I said, you cannot build a engineering structure without a design. My example was the 40 to 50 tall building without a blueprint. That's not going to happen if you don't have a design of the building first before you build it. So similar in software, you must have a design of the different parts of the software and how each of the part will interact with each other. And then we move on to coding. Once the design is uh, finalized or have a first approved design, we go to the coding. And here we apply agile software development. And the agile software development is a method of producing software in iteration, not uh, a single step. Like, for instance, if we finish the design uh, by second week, we don't. I don't expect you to finish the first prototype the following week, or the sixth week, uh, because by that time it will be too late to make any changes, supposing there is something wrong. So we have to have incremental steps and measure milestones along the days or weeks before the first prototype is due to actually um, develop it in parts rather than one big giant step to finish the first prototype. Then the SQAP, Software Quality Assurance Plan, the QA team will develop this document and they will test your prototype based on certain criteria of what the first prototype should have. And the prototype is given to the client, and the client tests it and gives you feedback. Then we go back again to coding, develop the, the second prototype. SQAP will test it and produce the second prototype by the end of the uh, quarter. This will be the the final prototype that will be given to the client. And if you decide to continue the project after the class is over, this is where we begin for the next iteration. If the client is interested in continuing the project. Okay? How do I terminate? Yeah, yeah. Another click? Yeah. Yeah. Okay. Uh, Many things to click. Okay. Um, our book define what is software engineering, and it defines it with four different terms. Uh, the author says it's a modeling tool, and it is. It's actually a representation of the software using a model, and that is why we use UML to actually measure, I mean, to represent the software using a model. And so it's like visualizing the software using a model or a picture of the software before it is implemented. The author also explains that it is problem solving tool, because it is a uh, um, a way of solving a particular problem. So usually the software solves a particular problem, and how do we solve it? So this is like a representation of how do we solve that particular problem. It is also knowledge acquisition, because the knowledge obtained from the the development gives you more knowledge to develop other software as well. And also, since it is a solution to a problem, it becomes part of your knowledge in solving similar problems later on. And then finally, rational driven, you want to find out the reason why behind, or why the software is built in a particular manner. So what's the reason driving the software to this particular implementation? So it's kind of a combined definition of what software engineering is. But I think the best definition of software engineering I have found is this one. Software engineering is the systematic application of engineering approaches to the development of software. So we are trying to be, we call ourselves software engineers, and therefore, if we are engineers, we must apply engineering approaches to the development of software. So we just don't, once you read the SRS, you don't sit down and write the code. No, we can't do that. There must be more understanding of the problem first. And since you are not a single person writing this software, it is a team that is writing this software, or probably several teams. So you cannot, everybody cannot just sit down and write the code. Yeah, there is no way you can do that, especially of the complexity of software that we face today. There must be a way to um, have a systematic approach. One of the principles we use in computer science in dealing with complex problems is divide and conquer. So that's a engineering principle of solving a complex problem. Divide and conquer. You decompose a very difficult problem into a components that you can understand, and if the component is still complex, you still break it down into its components until you find a particular level where you fully understand what that component is doing. That's called top-down design, or the divide and conquer kind of paradigm. Now, software engineering also is a combination of two fields. Software engineering is a direct subfield of engineering and has an overlap with computer science and management. As you can see here, um, it is not only computer science that you uh, must must deploy, like data structures and algorithm. We must also study management skills. You're dealing with people, you're dealing with deadline, and you're dealing with um, project completion. We cannot just have a project and be over budget, or you miss the deadline. That is not engineering. Engineering is the successful application of computer science methodologies and systems to the solution of the problem, but you also deal with management, and management is concerned with budget and time. When are we supposed to deliver a running project? Okay, so with that, I end lecture number 1, and um, next uh, the next set of um, lessons will be all about tutorials in the lab. I'll see you next time.